All right, our next case study is daily weather conditions. And the data set that we have to work with here is daily weather data from Boston, Massachusetts from January through December 2016. So we actually have just under a full year of data, 363 rows to work with. Got dimensions like date and the type of conditions, so clear, rain, snow, and then some measures to capture the max temperature for the day, the mean temperature, minimum temperature, maximum wind speed, and any precipitation in terms of inches. So the concepts that we'll cover in this kickoff include sorting and filtering, pivot charts, date grouping, and calculating with count. So let's jump right in. So in your pivot table case study workbook, go ahead and click on the daily weather conditions tab. And with any of these values selected, just press Ctrl A to grab the whole data range. We're going to insert a pivot on a new worksheet. We'll call this one Weather Pivot and format that tab color with a light green. And there we go. So we've got our starting point. And now to kick things off, I'd like to start by looking at average mean temperatures to see how things trend out day over day and over the course of months and seasons. So we'll start by pulling in date. You'll note that it auto groups them up to months. That's fine. I'm going to start by pulling months into the filters field so that I'm just looking by day to start. And then in terms of values, let's grab mean temperature and drop it into values. Now you'll notice it defaults to the sum, which because our data is at the daily level, that actually gives us the correct answer, but we don't want to sum these temperatures as we look at the data by month or by year or at any aggregated level or view. So what we can do is change summarization to average. As you can see, it's exactly the same as sum at the daily level, but now we'll be taking the average when we roll this up to months or years or anything else. So with mean temperature here, to help me kind of visualize how things are moving, I can select this entire column. I can actually get rid of the grand totals and just select the data itself. And from here, what I want to do is insert a color scale. So I'll go into Home, Conditional Formats, Color Scales, and I like this red to blue because blue kind of feels cold and red feels hot. So I'm going to choose this color scale specifically. And already, as you scroll through, you can see kind of how it shifts from blue to red and then back to blue as we head into the spring, summer, fall, and then winter. So that's pretty cool on its own, just as a visualization tip. Obviously, I can also apply sort options here. Say, okay, descending by mean temp will tell me the hottest day of the year, which was August 12th, with an average temperature of 86 degrees. I could either scroll all the way to the bottom or just change my sort options to ascending to see the coldest date of the year, which was Valentine's Day 2016. It's a really cold one. The average temp was 0 degrees, which is actually 11 degrees colder than the second coldest day, which was the 15th. And as you scroll through, it's kind of cool to see these color scales gradually shifting as the values change. So there you go. That's a nice way to kind of explore temperatures at the daily level. But now let's bring date out and pull month into the picture. So this tells us the same exact story here, just at a higher level of granularity. So now we can see the higher level trend by month, where January and February are very, very cold. It starts to warm up in April, May, June, and then you have July and August, which are the hottest, and then starts to chill down again in the fall heading into December. So this color scale does a really nice job visualizing the monthly changes in temperature, but I'd like to also add a line chart to help visualize this trend or show it even more clearly. So we'll go into Pivot Table Tools, Pivot Chart, and let's select Line here and press OK. I can get rid of some of these features. Don't need the field buttons. I don't really need a legend here since we're only looking at one series. And for the title, we can just call it Average Temp by Month. Make that title bold, spread it out a bit. And there you go. And just in terms of formatting, it's kind of nitpicky, but in a case like this, what I'd like to do is add data labels and then format them a bit. So I want to show them at the top, so above the data points. And I want to change the number format a bit. Let's Let's make it a number with maybe 1 decimal point, and then we can close that out. So that just helps kind of see the trend a little bit more. You can also format the data series, go into fill and line. I like to use a smooth line here as well. Again, that's just kind of my preference. You don't have to do any of that if you don't like to. But there you go. Now we see a very clear kind of bump up into June, July, August, and then a steady drop back down October, November, December. So from here we could also go ahead and add a timeline, since we do have a date field, and drop a timeline in as well. Essentially what this will do is it will give us kind of a tool that we can use to trim this view. So right now we're looking at all 12 months, but if we only care about the first half of the year, for instance, we can use the timeline to kind of adjust this view. Maybe we only care about the second half of the year. There you go, and you can see both the table and the chart updating accordingly. So nice little visualization tool that we can look to analyze temperatures by month. Obviously we could do the same exact thing with max temp, min temp, wind speed, precipitation. So I'd recommend exploring this and maybe testing out similar visualizations with different fields. So the next thing I want to demonstrate just in this case study kickoff is that now that I have a good sense of average temperatures by month, now I'm curious about digging a little bit deeper into the max and min temps. And specifically, I want to look at the temperature spread by day. So I want to see which days saw the largest differences between the max temp and the min temp. So instead of manipulating this pivot and ruining my chart, I'm actually just going to select that entire pivot table, copy it, and then paste it down here. So I'll preserve the work that we've done and just have a second instance of the pivot table to work with down here. So let's go ahead and pull months out. Let's go back to daily level, and I'll drag in the minimum temperature and the maximum temperature. Again, since I'm daily level, it really doesn't matter what summarization mode I use, but because I know I will be rolling these up to monthly at some point, I'm going to change these from sums to averages. And now I want to create a calculated field to give me that spread that I was talking about. So I'm going to go into Pivot Table Tools, Fields, Items, and Sets. Let's call it Temp Spread. And really the only thing that makes sense here is to take max minus the min, press OK. And this seems to be evaluating properly, at least on the daily level. So for any given day or date, I can see the spread. February 14th, the low was -9, the high was 12, which is a spread of 21. The 15th spread was from 4 to 35, which was a temp of 31. And I can use this temp spread field now as a sorting option. So let's sort descending by temp spread to see which day in our sample showed the largest difference between high and low temps. Turns out that was March 9th, where it had a low temp of 40 and a high of 77, which equates to a spread of 37 degrees. So this is cool and this is helpful, but now let's say I want to see this average temp spread by month instead of by day, to see if there's a larger spread for certain seasons or if there's some trend that might be interesting to see at the monthly level. So let's swap date with month, and here we see that our temp spread all of a sudden is totally crazy. So we're seeing a temp spread of 433 degrees in January, and by this point you should start to get a sense of why this type of error occurs, and it's because temp spread is a calculated field. Calculated fields need to use sums for any input fields that go into the formula, and in this case the input fields are minimum temperature and maximum temperature. So what I realistically want is a formula that says subtract the average minimum temperature from the average maximum temperature and give me that difference. So in this case, really what I want is 39.484 minus 25.516. So this really should be evaluating to 13.97 instead of 433. But like we talked about, we can't go into our calculated field, go into our temp spread, and we can't say, give me the average max temp minus the average min temp. That just doesn't work. So what we need is a helper column or a new column in our actual data set that will take the count and evaluate it as a sum that we can use in our formula. So let's go ahead into daily weather conditions. Let's just add a new column after A. We'll call it number of days. Since our data is at the daily level, it's just going to take a value of 1. You can see it defaults to a date format, so let's just change that to a number and apply it down. So now we've got a value of 1 in every row for this new number of days column. Now back in my pivot, we can go ahead and refresh that pivot. There's number of days. And now what we need to do is convert that formula that we had written from sum of max temp and min temp, which is the default, the only option we have. We need to change this to the average max and the average min. So to evaluate the average max temperature, we can now take the max temp or the sum of max temp and divide it by the number of days. That's the same thing as taking the average max temp. And I'm going to do the same thing here with minimum temp, open a parenthesis, divide it by the number of days, and close it off. So now this translates to the average max temperature minus the average min temperature. Press OK. There you go. So 13.967. I can just add that manual calculation in as a spot check again, drag it down, and it's right on point. So that new formula that we had written using that counting column in our raw data did exactly what we wanted it to do. And from here we can simply format this, in a more user-friendly way. We can even pull out min and max if we choose. But now, as always, we can sort based on that new field to say, okay, in general, February, at least in 2016, was the year with the largest average temperature spread of just over 18 degrees, whereas December had the smallest average temperature spread of 13.36. So kind of interesting. Not sure there's much of a trend here. Looks like the summer months, like June, July, August, tend to show pretty large temperature spreads here, and the colder months tend to show smaller, although February looks like an exception to that rule. But anyway, just another interesting angle that we can use to analyze this weather data. So there's our kickoff for the daily weather case study. Give the homework questions a shot, and let me know if you have any questions.